Hello, today I'm going to go over how you derive backpropagation for a linear layer with batch input. So this is going to be pretty similar to a linear layer with a vector input, except now X is going to be a matrix. So Y is WX plus B, so if we expand it out, then Y is also going to be a matrix. Y naught 1, and so on. Y 1 naught, Y 1 1, and so on, is going to be equal to the matrix W naught naught, W naught 1, and so on, W 1 naught, W 1 1, and so on, times X, which is a matrix, so X naught 1, X, no, sorry, not naught 1, naught naught, X naught 1, X 1 naught, X 1 1, and so on. And then I'm going to use this cross symbol to mean broadcasting the addition across the matrix, which you'll see what I mean now. B naught, B1, and so on. So if, like we did before, we do the matrix multiplication, so if I copy this over, so it's going to be equal to, so W naught naught times X naught plus W naught 1 times X 1, and so on. X naught naught plus W naught 1 X 1 naught, and then W 0 0 0 0 X 0 1 plus W 0 1 X 1 1, and then plus, obviously, plus dot dot dot, plus dot dot dot, and so on, and then W 1 naught times X naught naught plus W 1 1 times X 1 naught, and so on, and then W 1 naught times X naught 1 plus W 1 1 times X 1 1 plus dot dot dot, and then so if we consider an element Y I J, then say now if we consider Y 0 1, then that's this. So as you can see, this is incrementing and this is incrementing, and then these remaining fixed. So you can see that, well, it's the sum over K, and then W, and the element which is remaining fixed is this is the first element, and then, so if this is I J, then this is I, and this is J. So it's going to be WIK times XKJ. And then, oh, I forgot to add on the biases here. So if if I just move this across, we should have then plus b0 plus b1 and plus b0 plus b1. So as you can see, the addition is from this element has been broadcasted across the whole row in this matrix. So that's what I mean by this cross plus broadcasted addition. So plus b and then in the same row, so I. So then we can take the partial derivatives of yij with respect to wik, which is just xkj. We can take the partial derivative of yij with respect to xkj, and that's just wik. Oh, I need to do these. wik, and then the partial derivative of yij with respect to bi is just 1. So again, we'd have the loss already passed back to this layer, so we'd already be given del derivative of the loss with respect to y, and that would be a matrix like this: del L by del Y 0, 0, del L by del Y 0, 1, and so on. Del L by del Y 1, 0, del L by del Y 1, 1, and so on. So if we want to find the derivative of L with respect to W, then we start with one element of W. So the derivative of the loss with respect to some element, and I'm just going to wik of W is going to be the derivative of L with respect to yij times the derivative of yij with respect to wik, and as you can see here, wik is, so let's say now w 0, 0 starting off in one dimension, but it's going to more than one dimension, so we're going to have to use the multivariate chain rule we're going to have to sum over the j's. So as you can see, it's summing over the second axis. So as you can see here in the x, the coefficients of W0, 0 are incrementing over the second axis, so it all adds up. But yeah, so if we evaluate this, then it's the sum over j of the derivative of L with respect to yij, but we've figured out the derivative of yij with respect to wik is just xkj, so times xkj. So now if we write out the whole matrix for del L by del W, so on the first row I is going to be equal to 0 or 0, so, and in the first column k is going to be equal to 0, so if we sum, it's the sum over j of del L by del Y and then I, which is 0, times j, not times j, just ij, x, and then k, which is 0, j, and then the next entry, k, is going to be equal to 1. So it's the sum over j of partial of the loss with respect to y, and then I is the same, so it's just 0j, x is 1j, and so on. And then in the next row, I is going to be equal to 1, so it's the sum over j of partial L with respect to partial y, 1j, x, 0j, sum over j, partial L with respect to partial y, 1j, x, 1j, and that carrying on. So if we write these out, write the sums out as well, just to make it clear, then this is equal to, so with j is equal to 0, this whole thing is going to be del L by del y 0, 0, x 0, 0, and then with it equal to 1 is going to be 0, 1, x 0, 1, and then that's going to carry on, so just incrementing the second index, and then this whole thing when j is equal to 0 is del L by del y 0, 0, x 1, 0, plus del L by del y 0, 1, x 1, 1, and that's going to carry on, and also the whole thing's going to keep going, and then this thing is going to be del L by del y, and then so with j is equal to 0, it's going to be 1, 0, 0, 1, so 1, 0, no, not 0, 1, x 0, 0, plus del L by del y, and then with j is equal to 1, it's going to be y 1, 1, x 0, 1, and then that sum carries on, and then after that it's partial L respect to partial y 1, 0, x 1, 0, plus partial L with respect to y, and then it's going to be 1, 1, x 1, 1, plus dot dot dot, carries on, and then that would carry on down as well. And as you can see, this is, so partial L, partial y 0, 0, partial L, partial L by partial y 0, 1, and so on. Second derivative, partial derivative of L with respect to sort of y 1, 0, L with respect to y 1, 1, and then times by, so this times this plus this times this makes this, so it's x 0, 0, x 0, 1, and then so this times this plus this times this as this. So it's going to be x 1 0, x 1 1. And yeah, as you can see, this pattern works for this as well. So this times this plus this times this is this. Yeah, so these are all just, so this is the partial of L with respect to y, and this is x transpose. So next we want to find the derivative of L. So just this is del L by del W. So next we want to find the partial derivative of L with respect to x. So we start off by finding the partial derivative of L with respect to one entry of x. So say now x kj. So del L by del x kj is equal to the partial of L with respect to y I j, partial of y I j with respect to x k j. So as you can see here, we need to sum over the I. So sum over the I. And we know that the partial derivative of y ij with respect to x kj is just wik. So we can rewrite this as the sum over I of partial L partial y I j times w I k. Is that right? I k. W I k. Yeah. So again, if we write out the matrix for del L by del x, then we're going to find that, so the first row k is equal to 0, second row k is equal to what? K is equal to 1, not x, and then so j is going to be equal to 0 in the first column. So if we rewrite this with k is equal to 0 and j is equal to 0, we're going to get the sum over I of del L by del y and then I 0 times w and then I 0. And then the next entry we're going to get the sum over I of the partial of L with respect to, well here j is going to be equal to 1, partial of L with respect to y I, and then j is going to be now 1, y1, I1, w I k, which is 0, so I 0, and so on. And then this is going to be sum over I of del L by del y I 0 w I 1, and then this is going to be the sum of I of del L by del y I 1 w I 1. And so again, if I write out these sums, then we're gonna find out how to write this in matrix form. So if I write, so with I is equal to 0, the first entry is going to be del L by del y 0 0 w 0 0 plus, with I equal to 1, it's going to be del L by del Y 10 W10. Yeah, plus dot dot dot. And then if we look at this second entry 0, 1, then it's going to be with I equal to 0, we're going to have del L by del Y 0, 1 W 0, 0 plus del L by del Y 1, 1 W 1, 0. And then that carries on, and then this whole thing would carry on as well. And then, so entry 1, 0, so with I equal to 0, we'd have del L by del Y 0, 0 W 0, 1 plus del L by del Y 10 W 1, 1 plus dot dot dot. And then the next entry would be del L by del Y 0, 1 W 0, 1 plus del L by del Y 1, 1 W 1, 1 plus dot dot dot. And now it's easier to see that you can write this as, so W0, 0 W10 W20 dot 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 time, and then the next row would be W 01 W11 W21, and then the next row would be W02 W12 W22, so on, multiplied by del L by del Y 0, 0 del L by del Y 1, 0, so on, del L by del Y is that 1? Oh wait, no, this shouldn't be 1, 0, this should be 0, 1, and then 1, 0 del L by del Y 1, 1. So look, if we take this times this plus this times this, then get this, and so on. So this is just, this is just W transpose times del L by del Y, which is del L by del X. And then finally for the bias, del L by del B I is del L by del Y I J del L by del B I. Oh no, not del, not L at the top. Y I J at the top. Y I J. So as you can see, it's going into from one dimension into many dimensions along this J index. So we need to sum over the J's. And we know that partial of Yij with respect to Bi is just 1. Oh, I need to write this here. So this is just the sum over J of partial L with respect to partial Yij. So I think that's as simple as you can get this formula. So partial L by partial Bi is equal to sum over J of partial L by partial Yij. So essentially, if we have B here or the partials of the partial derivatives of b with respect to the loss, and then these are just the sum over the rows of the partial derivatives of y with respect to the loss. So if we just write down the formulas, then that should be the whole thing done. So the partial derivative of the loss with respect to the weights is respect to y x transpose. So partial L with respect to y x transpose. Partial of L with respect to x is W transpose partial L partial y. And then we've got this slightly less nice formula for the bias. Partial L by BI is the sum OJ of partial L by partial Y IJ. So there it is. Thank you for watching.